All right, so on your homework, let me move this to the side here. So when you do number 9, A, B, and C, what we did in the old days is you had to solve for what? So everybody did it that way then? There was some of you are thinking there was homework. Where is it? Gosh, my eyes are bad. 9C, 3x squared minus 2xy plus y squared minus 4 equals 0. Okay, this is not a function because of that y squared there. So what do you do? How do you graph something that's not a function? Because your calculator only graphs functions. So what you need to do is you need to solve for y by putting it in quadratic form like this. So the coefficient of y squared is 1. The coefficient of y is negative 2x, and everything that doesn't have a y in it is this. So to solve for y, using the quadratic formula, you get negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course you can simplify it if you want, but and then you just tell your calculator to graph, but then Mr. Park, where's the plus or minus button? There is no plus or minus button. So you have to graph y1, which is the one with the plus sign. That will graph the upper half of whatever the graph is. The minus sign will graph the lower half of the graph, and if you put it together, you get the whole graph. But that takes so much work. Now you guys have an HP prime, you just do advanced graphing. All you have to do is punch it in exactly like this, and then boom, the thing just graphs the whole thing already. And let me tell you what it's going to be. B squared minus 4, it's going to be a tilted ellipse. That's what it's going to be. So here, let me show you how. Okay, so go to apps. Wait, make it louder so the camera can hear. Apps, go to apps. Hey, go to apps. Apps, apps, check 1. Go to apps. There, you see advanced graphing? Click on advanced graphing and just punch it in exactly. You don't have to do anything. So I think you have to use the time sign though. 3 times x squared minus 2 times x times y. Where's y? Alpha 1 plus y squared. So plus alpha 1 squared. Ooh, minus 4 equals 0. So here's the equal sign, and there's 0. Enter. Let's see if it accepts it. Yep. And there you go. Let's press plot. Boop. There. Tilted ellipse. So you don't even have to do this quadratic formula anymore. Oh, shoots. I can't pinch in and out. Of course you can zoom in. Now remember, if you want to get credit on your homework, you got to show this now. You got to like draw what you see on your calculator on your paper. Because every single year, the students go, I didn't know I was supposed to do that. Well, how do I tell that you did your homework then? And then, yeah, so if I give you this problem and the probability is quite high that it's there, just do advanced graphing. It's way easier. Okay, I'm going to minimize this one then. And then look at number 10. Oh, we got to know the binomial theorem, right? You can't do number 10 if you don't know the binomial theorem. So tomorrow, what would be a good problem on a quiz? X to the 1/2 power. Show at least the first 4 terms or something. I don't know, I'm just thinking out loud. Okay, so tomorrow the quiz is on what? Binapsonic 3, absolute value. And then function 1. Okay, I'm pretty sure that's gonna be a kind of long quiz, so let's make it 50 points. Okay. In fact, the next one's gonna be pretty long too, so maybe the next two will be 50 points. Okay, this is what we're doing today. Graphing. It's just a whole bunch of graphs you gotta draw tonight. All right, so let's go over all the graphing things. This is all in your notes. Everything is in the notes. Some of you are still taking notes furiously, but it's all in the notes. Just look at the notes. If you know what the graph of a function looks like, how do you graph this? This is all things we learned starting from Algebra 1, then Algebra 2, and then of course in geometry you learned about, what do you call it, dilations and translations, right? What's that? Okay, anyway, what does this do? It reflects the graph over the y-axis. So reflect over y-axis. Now students, okay, when they see it, they can do it, but you gotta understand what happens. If you plug in negative x for x in any function, it reflects the graph over the y-axis. It doesn't matter what the function is. If you plug in negative x for x, that's what it does. What about this? What happens when you multiply the whole function by -1? It's going to reflect it over the x-axis. By the way, these are all things you got to know on the SAT and PSAT, right, and ACT. Okay, the next four, I don't know why, but students can remember these. What does this do? It will shift the graph 2 to the left. See, when it's inside the parentheses, it kind of does like the opposite of what you think it is, yeah? See how it's in the parentheses? So you +2, but you actually shift it to left. And when it's inside the parentheses, it affects left and right, right? When it's outside the parentheses, it affects up and down. So what about this then? This will shift the graph 3 to the right. You know what, I'm not going to even write these things down because it's in the notes. Plus we should know it by now. What about this? This will shift the graph 1 to the up. See how it's on the outside? So it's like +1, you think it's up, it is up, but when it's inside the parentheses, it's like opposite. And this one will shift it 4 to the down. Goes 4 to the down. Everybody remembers those. All right, get rid of this. Okay, what are the ones that, oh, what about this? What does that do? How did you guys learn it last year? Go ahead, Mr. Rubash. So didn't you guys do like mocks and mats? Does he still do that? How come some people say yes and some people say no? I don't get that. What is mocks then? You guys are funny. So what is this? How did you guys learn it? What about, okay, I know Mr. Cropsey. Mr. Cropsey does, this is a horizontal shrink. Okay, anyway, this shrinks the graph by a factor of 2 horizontally. That's what it does. Okay, but I don't like that description of it. When I see this, I think you're going to multiply every x coordinate on the graph by 1/2, which of course results in a horizontal shrink. So I just think multiply the x values by 1/2. See, again, it's in the parentheses, so you do kind of like the opposite of what you think it is. What about this then? What will that do? This will multiply the x coordinates by 3, the reciprocal of that number, which results in a horizontal stretch by a factor of 3. Okay, so how did Mr. Cropsey teach you? Stretching and shrinking? Yeah. And Mr. Rubash, same thing, stretching and shrinking. Or, you sure not Max and Max? Okay, who had Mr. Rubash? Okay, so almost everybody here. So then, Kylie.
Kylie.
Kylie. What did Mr. Rubash say?
I don't remember.
What? Okay, it's better that way. Just do what I tell you. That's probably gonna work. So when it's inside the parentheses, multiply the x coordinates by the reciprocal of that number, 1/2 and 3. What about when it's on the outside like this? What does this do? This will multiply the y coordinates by 4, which results in a vertical stretch. And then what about like something like this? This will multiply the y coordinates by 1/5, which results in a vertical shrink. I don't really care how you think of it. I mean, it's the same thing, but you know when you're drawing graphs, because you're going to have to draw a lot tonight, it's just easier if you think multiply the x coordinates by 1/2, multiply the x coordinates by 3, multiply the y coordinates by 4, and multiply the y coordinates by 1/5. Okay, now those of you in Mr. Rubash's class, now is Max and Max. Max, Max, multiply the ordinate by something. Multiply the abscissa by something. Then who are the people saying yes then Max and Max? There are a few people going, yes, we did it, then that's... Okay, whatever. What about this? What about when you put absolute value on the whole thing? What does that do to the graph? Everything, okay, here, let's say this railing is the x-axis. Everything below the x-axis gets reflected above. Some of you are looking at me like, huh? This is the easy one. Everything that's above the x-axis, you leave it here. We need an example. Suppose you have a graph that looks like this. If I put the absolute value on the whole function, what is that going to do to it? Everything above stays the same. See, when it's positive, you leave it alone, right? Remember absolute value. But if it's negative, you negate it. So what's going to happen? Everything below gets reflected above. Boom. That's how you graph this. Okay, but what happens when you put absolute value only on the x, not the whole thing, only on the x? What does that do? Come on, Mr. Cropsey told me he drilled this into you. Who had Mr. Cropsey? You had Mr. Cropsey. Only one person had Mr. Cropsey, Cruz. Okay, what does this do?
It gets rid of everything on the left and reflects the x over the left.
There you go, that's what I'm talking about. Okay, so suppose you have a function that looks like this. Whatever. If the absolute value is only on the x, you erase everything to the left of the y-axis. It's just gone now. And then whatever's on the right, you keep it, and then you reflect whatever's there about the y-axis. That's how you graph this. Does that sound familiar now? Erase. Anyway, it's in the notes. Look at the notes. Okay, these are all the graphing transformations you need to know. Okay, so what kind of problem are you gonna have on tonight's homework? Okay, here, let me show you something. Okay, I don't want to do the exact same one up there, but maybe I should. Because what do you guys do? Do you guys actually do the homework first and then look at the video or the solution? Or do you look at it and go, oh, I copied it down. Oh, I do my homework so fast that way. Oh my goodness. Okay, you know what? I'll just do this one. Okay, so you know what? What are the key points there? -2, 0. What is that point? 2, 2. Gosh, my eyes are pretty bad at 2, 2. And then that looks like 4, 0. You're gonna get almost the same thing. Okay, so here's the graph. Okay, let's do one. Let's do D. graph y equal 3 f of 2x. Well, what does this do to the graph? It multiplies the x coordinates by 1/2. What does that do to the graph? It multiplies the y coordinates by 3. So here are your key points. Look, I'll even write down the coordinates. Okay, let's do this one in red. If I multiply the x, look, here are the 3 key points. Multiply the x by 1/2, multiply the y by 3. Multiply this by 1/2, multiply that by 3. What are you going to get? -1, 0. That's where the point goes then. Same thing here. Multiply the x by 1/2. Can you guys do that in your head? And then multiply the y by 3. 1/6. No. So 1/6. Now that point goes up here. What about this point? Multiply the x by 1/2 and the y by 3. 2, 0. Connect the dots. Oh, I missed. Just make it a little bushy like that. And there you go. That's what the graph looks like. Because you know what? Some students do some crazy things. They start working with the equations. Yeah, you can, but it's like, it's not efficient. Just take the key points and do what you're supposed to do to them. Okay, what else looks interesting up there? Okay, oh, G. I can guarantee you this one is going to be on the quiz, probability 1. And for those of you who still haven't figured it out yet, that means guarantee it's on there. So what is G? Y equals, I was just looking at it and I forgot already. 2 minus x. See, but what the heck is going on? See, but the problem is, if I do this for you now, some of you think, oh, I don't need to do it for homework, and then what's going to happen when it shows up on the quiz? Pain, that's what's going to happen. Okay, now, there's 2 ways of, it just came into my mind. Mr. Cropsey said he did lots of these last year, right? What about Mr. Rubash? Did he do lots of these? Well, it doesn't matter because I'm going to give you a lot. I'm going to give you this over and over and over until you get it. Every time you get to the next chapter, I'm going to give you that again. Now, there's 2 ways of thinking about this. You can go f of negative x plus 2. Isn't that the same thing? Okay, or you can go f of negative x minus 2. Isn't that the same thing? Okay, here is the hard part for students. Okay, let's do this one first. There's 2 things going on. What does that do? Reflect it over the y-axis, right? What does this do? Forget that minus x, that thing. Shifted 2 to the left, right? But which one do you do first? Because the order, see, sometimes the order doesn't matter. Like in this problem, it doesn't matter if you multiply the x's by 1/2 or multiply the y's by 3 first, right? Same result. But some problems, it makes a big difference which order you do it in. So this one will shift it 2 to the left, but that reflects it over the y-axis. Which one do you do first? This is what students do every year. They just guess. They make up their own. So what you do is you got to figure it out. Okay. Okay. So here are the 2 choices. You either shift it 2 left first and then reflect over the y-axis, or do I reflect it over the y-axis first and then shift it 2 to the left? A or B? Come on, somebody take a stand here. Huh? Okay, I heard some B's. Okay, here. This is how you check this. Okay, here's A. This is how you check to see if it's right. How do you reflect the graph over the y-axis? Don't you substitute negative x for x? Okay, now, how do you shift the graph 2 to the left? You substitute x plus 2 for x. So if I substitute x plus 2 for x like that, is that the same thing as that? No, so that's the wrong order. Fatal error. Because how do you shift the graph 2 to the left? Don't you substitute x plus 2 for x? Then, how do you reflect the graph over the y-axis? You substitute negative x for x. Is that what we want? Where did it go? Here. Is that what we want? Yep. That's what you do then. So that's what you do. You shift the graph 2 to the left, and then you reflect it over the y-axis. But every year, you know what students try to do? They try to memorize it or something. Well, why not just figure it out? Okay, let's get some different colors here. Let's do orange, let's do green, orange is fine. Okay, so here's the white graph. We're going to shift it 2 to the left. So here's the key point. Shift it 2 to the left, which is going to be negative 4, 0. And then reflect it over the y-axis. That means it's going to be here now, right? Okay, here's another key point. Shift it 2 to the left, and then reflect it over the y, so it's the same place. And then this point, shift it 2 to the left, and then reflect it over the y-axis. It goes here. Connect the dots. And there's your picture. There's your graph. Now, the other way that you can think about it is this way. Let me erase this thing here. Okay, so let's just do it here. Y equal f of negative x minus 2. Now there's two things going on here. This reflects it over the y. This shifts it 2 to the right. But which one do you do first? Does it matter? The answer is yes, it doesn't matter. So there's two choices. Reflect over the y-axis first, and then shift 2 to the right. Or should I shift it 2 to the right first, and then reflect it over the y-axis? Okay, again, I'll give you two choices, A or B. Okay, I heard B's again. Okay, let's try that. If you shift the graph 2 to the right, what does that do? You substitute x minus 2 for x, right? How do you reflect the graph over the y-axis? You substitute negative x for x, like that. Is that what we want? That's the wrong one then. Here, maybe you know what you guys should do then? Think of the one you think it is and then pick the other one then. I just don't know. Okay, what about this? Reflect the graph over the y-axis. That's this, right? Substitute negative x for x. Then shift it 2 to the right. How do you shift any graph 2 to the right? You substitute x minus 2 for x. Is that what we want? Yes, so that's what you do. So let's do a different color here. All I have left is green. Okay, so look at the white graph. We're going to reflect it over the y-axis and then go 2 to the right. So look at the white graph. Reflect it over the y-axis and then go 2 to the right. That's this point right here. Okay, here's this point. Shift it 2 to the right and then reflect it over the, wait, are we going? No, I'm doing the wrong one. Reflect it over the y-axis first and then go 2 to the right. And then here's the point. Reflect it over the y-axis and then go 2 to the right. But then look, it's the same thing. And that's why you can think of it either way. It doesn't matter. You can think of it that way or that way. Okay, so how are you guys going to organize this in your mind? Because this, I'm telling you, this is on the quiz. It's going to be on every quiz almost, starting from now. Every time we come across a new function, when we do exponential, logs, trig functions, I'm going to keep giving you that until you get it. Maybe you guys should just pick one way and just memorize. That's what some people did last year. Here, like over here. Like if you're going to think of this way, what do you do first? You shift it 2 to the left and then reflect. So shift, then reflect. Shift, so this way you shift first and then reflect. But then if you do it this way first, you're going to reflect it first and then shift. So this is rising sun. But then this one is sunrise. I just made that up. You guys have to organize this, not me. That's why I would really suggest you don't memorize it. Just figure it out. Okay, so that's probably the toughest one there. Oh, what about inverse? How do you graph inverse? I need another color. No, we're just gonna make a new one. Okay, what was the original graph? Why am I doing your homework? You guys are lucky. I'm not gonna do this in the other two classes. I'm just gonna make a new one. Okay, how do you graph the inverse of any graph? What do you do? What did your teacher teach you last year? How do you graph an inverse? You switch the x's and y's. That's how you get an inverse. Here, I even give you the coordinates. 2, 2, 4, 0. All right. So, I have negative 2, 0. What happens when you switch it? You get 0, negative 2. That's how you get the inverse. This is 2, 2. You switch it, you get 2, 2. This is 4, 0. What happens when you switch it? You get 0, 4. Connect the dots. And then what did you learn last year? Anytime you graph any graph and its inverse, they will be symmetric about the line. Really? Y equal x. And are they? Yeah. That's how you check your answer. Anytime you graph any graph and its inverse, they should be symmetric about the line y equal x. That's a really important property of inverses, as you will find out as we go along. And then, see, this is the kind of problems that you're going to have on the quiz. You see, look at number 2. I'm going to give you a face, and then you're going to have to write the equation of, like, the eyebrows or the mouth, or I might put a nose in or something. Which means there, like this. Here is a semicircle function, right? That's why you have to know the semicircle function now. Okay, here's the semicircle radius 1. What do I have to do to this graph, stretching, shrinking, translating, whatever, to get the face like that? That's what you're going to have to do. Okay, so I'll leave you to it. And then number 4. Oh, by the way, do you guys even know how to find inverses? What's the procedure? What the heck is going on? Yeah. What the heck is going on? I'm going to erase this. So if you have f of x is equal, I'm not going to do the homework, I'll make it similar. How about 2x plus 3 over 5x plus 7? See, different numbers there. How do you find the inverse of this? So find f inverse of x. What did we just learn? This is like y, right? How do you find inverses? Come on, this was drilled into you last year. You switch the x's and the y's. So and then you solve for y. It's very mechanical. Switch the x's and y's. Solve for y. Now, how do you solve for y? Cross, multiply. This is just algebra here. There's 2 terms with y in it. Put it all on one side. I don't care which side. It doesn't matter. Put everything else on the other side. Factor out the y. And then divide. This is just simple algebra 1. Shoots, I'm pretty much doing every single problem that's going to be on the next quiz right here. There you go. That's the inverse. And remember, how do you check your work? Now, last year, I know the book made you check your work, but I'm not going to make you check it. You guys are just supposed to know already. How do you check your work to see if you did it correctly? If you take this answer and plug it into the original function, in other words, here and here, what should you get? I'm having a meeting with Mr. Rubash and Mr. Kropsy. So if you have a function and it's inverse, if you plug one into the other, and it doesn't matter which way you do it either, you can plug the function into its inverse, you will get the same answer every time. And what is that answer? Why don't I just tell you it's x? Now does that sound familiar? This is super important in calculus, you know. If you don't know this, it's gonna be very, very difficult. Do you have to remember all this stuff? Yes. This is the, I don't, see, this is what I think has happened last year. You guys memorized stuff for the quiz, purged, then next one, next quiz. Memorize, purge. Am I correct? Kind of. See, that's why you're having problems. But this year, you guys are trying to fight me, but everything we learn, we're going to keep using it. It's a tool. It's not something to be thrown away. Okay, anything else I gotta teach you? So, no, I don't. So, you know all this stuff about shifting the graph, reflecting it, and things like that, it's gotta be in here. So you gotta know what to do. Okay, you know what? I'm gonna do a problem like number 4, because I think it's necessary. Okay, so suppose you have any function, it doesn't matter what, okay, I'll just make, how about 2x plus 1 over 3x plus 4? Just different numbers. Okay, you don't know what this graph looks like, but what if I tell you, okay, take this graph and shrink it horizontally by a factor of 3. How do you shift this graph horizontally by a factor of 3? What do you do? Is it this? Is it this? Is it this? Or is it this? Which one shrinks it horizontally by a factor of 3? It's a 1 out of 4 chance. It's this one! Right, because it multiplies the x coordinates by 1/3. That's a horizontal shrink. So all you have to do then is substitute 3x for x like this. That will shrink the graph horizontally by a factor of 3. And then you're going to have to do several of them in a particular order. Okay, let's do another, just do one more. Okay, here's your original graph. Okay, let me think of something. How do you reflect this over the y-axis? Take this graph, reflect it over the y-axis. What's the new equation going to be? Well, what reflects a graph over the y-axis? Is it this or is it this? The first one. So all you have to do is wherever you see x, you plug in negative x like this. That reflects it over the y-axis. And of course, do you guys know that these are simply special cases of this, right? Because look, you can also think of this, oh, that multiplies the x coordinates by -1. If you multiply an x coordinate by -1, doesn't it reflect it over the y-axis? Or this multiplies the y coordinate by -1. If you multiply a y coordinate by -1, it goes from 2 to -2. It reflects over the x-axis, right? So maybe you guys should think about it that way, instead of just memorizing. I mean, yes, you have to memorize stuff in this class, but it's better to just understand how it all works. That's what I'm trying to teach you, but many of you are fighting me. Because it worked last year, Mr. Park, but well, is it working this year? Maybe it still is, but I'm trying to teach you how to think, how to do problem solving. We haven't even got to do the hard problems, and this is just review from last year. What's going to happen when we get to the new stuff in the second semester? I'll worry about it then. All right, we are done. I just want to see what tomorrow's lesson is. Tomorrow's lesson is, oh, word problems, my favorite. Look at that.
Yeah, I need to.
Mr. Tom,
Uh-huh.
so if I'm using calculus, do I